This lesson is from Mrs. Cucci's College Now PreCalculus class. We are on lesson 5.1, Trigonometric Functions of Acute Angles. So go ahead and get that opened up and we'll get started. Okay, so by the end of this lesson, you will be able to determine the 6 trig ratios for a given acute angle of a right triangle, determine the trig function values of 30, 45, and 60 degrees. Using a calculator, find function values for any acute angle, and given a function value of an acute angle, find the angle itself. And then given the function values of an acute angle, find the function values of its complement. Okay, so those are the goals for the end of this lesson. All right, so just a reminder, our trig ratios, sine is opposite over hypotenuse, and going along with its reciprocal trig function, cosecant, that's going to be hypotenuse over opposite. So again, it's just the reciprocal of the ratio. Cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. Tangent is adjacent over opposite. And cotangent is opposite over adjacent. All right, so here what I have is I have a right triangle with the sides and the angles labeled. It's a 5, 12, 13 triangle. Up here I've got alpha, and down here I have theta. We're going to use this triangle to determine the ratios of our trig functions. Okay, so first we're going to look at the angle theta, and we're going to find all 6 of our trig functions. So sine theta, cosine theta, and tangent theta, as well as their reciprocal trig functions. Cosecant theta, secant theta, and cotangent theta. So we have to remember our SOHCAHTOA. We've talked about this for quite some time now. Okay, SOHCAHTOA, if you remember back to 9th grade. All right, so sine. So again, we're going from theta, so right here. Okay, sine is the ratio opposite, so directly across from it, which is 12. Over hypotenuse, which we know is opposite the right angle, over 13. Cosecant, we can very quickly find this because we know it's the reciprocal of sine. We can simply take this ratio here and flip it. Okay? We take the reciprocal. Cosine is adjacent. Adjacent is connected to it over hypotenuse. And secant is going to be the reciprocal of that, so 13 over 5. Tangent is opposite over adjacent. Cotangent would be the reciprocal. Okay, so now we're going to do the same thing, except we're going to use alpha this time. So we're going from here. Okay, so we're starting again with alpha. We want sine of alpha. Sine is opposite over hypotenuse. So we're going to have 5 over 13. The reciprocal of that is 13 over 5. Cosine is adjacent over hypotenuse, or 12 over 13. The reciprocal being 13 over 12. And tangent is opposite over adjacent, 5 over 12, and cotangent being a reciprocal of that, 12 over 5. Okay. So we already went through and we did all of these, so you can put those in as you go. So now let's talk about our reciprocal functions. Again, reciprocal functions are simply that. They're our reciprocals. So cosecant theta is going to be 1 over sine. Secant theta is 1 over cosine, and cotangent is 1 over tangent, or cosine over sine. The reason being is we know that tangent is sine over cosine, and cotangent is simply the reciprocal of that, so the reciprocal becomes cosine over sine. That's where that comes from. Okay. Okay, so given that sine of phi equals 4/5 and cosine of phi is 3/5, tangent of phi is 4/3, we're going to find cosecant, secant, and cotangent. This is another Greek letter. It's pronounced phi. Okay. So what we're going to do is we're going to take the information that we were given, and we're going to use that to find the missing information. So again, we were given sine of phi equals 4/5, cosine of phi equals 3/5, and tangent of phi equals 4/3. We want to find cosecant, secant, and cotangent. Cosecant we know goes with secant. Secant goes with cosine, and cotangent goes with tangent. They're the reciprocals. So again, all I need to do, since I know that they are reciprocal functions, is to take those values and simply take the reciprocal of them. Okay, so let's take a look at another one. I've got sine of beta equals 6/7, and beta is acute angle, so that means less than 90 degrees. Find the other 5 trig function values of beta. All right, so if you remember back to Algebra 2 trig, we actually did quite a few of these, okay? And we said it's a positive acute, so it's going to be less than 90 degrees. So that's going to be quadrant 1 for us. Okay. So what I'm going to do is I'm actually going to build myself a right triangle. Since I know we're dealing with right triangle trigonometry, we can actually create ourselves a nice triangle in order to find the remainder of these values. You pick an angle to be beta. Doesn't matter if I choose this angle or this angle, just as long as I set it up accordingly. We know sine is the ratio of opposite over hypotenuse. So my opposite from beta, from my angle beta, my opposite side is going to be 6. And my hypotenuse is going to be 7. So since I'm looking for the 5 other trig values, what I need to do is I need to find that side adjacent. So since this is right triangle trig, we know we can use the Pythagorean theorem. A squared plus B squared equals C squared. Okay, A and B being your legs and C being your hypotenuse. So we've got 6 squared. Sarah sharpening her pencil. 6 squared plus B squared, because we're missing that leg, equals 7 squared. Okay, we're going to go ahead and solve for B. So we get 7 squared minus 6 squared, and then take the square root, and we get B to be the square root of 13. Okay, so I'm going to label that side. So now we're going to go through that. Now that we have all of our sides, we're able to find all of our ratios. So let's find cosine of beta, tangent of beta, and then my reciprocals. Cosecant of beta, secant of beta, and cotangent of beta. So again, going from this angle, cosine is adjacent over hypotenuse, so we're looking at the square root of 13 over 7. The reciprocal being hypotenuse over adjacent, so 7 over the square root of 13. Tangent, opposite over adjacent. Opposite is 6. Adjacent is the square root of 13. Cotangent, square root of 13 over 6. So the last one we need is cosecant. Cosecant is the reciprocal of sine. We know sine is opposite over hypotenuse. So cosecant is going to be hypotenuse over adjacent, 7/6. Okay, so if you're given what sine of a given angle is equal to, you can set up a right triangle based on that ratio, find the missing side, and then find the other function values. Okay, so now we're going to talk about function values of 30, 45, and 60. If you remember from last year, we did quite a bit of work with two special right triangles. We're going to do that again this year. Okay, so here's your two special right triangles. We have our 45, 45, 90 triangle. Remember that the opposite sides from the angles, if the angles are congruent, so are the opposite sides. So we've got 1, 1, square root of 2. And then our 30, 60, and that goes 1, 2, square root of 3. So these should be memorized. Okay, so make sure that you take the time to do that. Because if you remember correctly, all of your points from your unit circle come from these two triangles. So they are very important that you remember these. All right, so I'm going to build a table from these two triangles. Sine at 30 degrees. So if I go back, sine at 30 degrees. 30 is opposite over hypotenuse. So sine at 30 is 1/2. Okay. Similarly, cosine at 30, which we know is adjacent over hypotenuse. Adjacent is the square root of 3 over 2. Hypotenuse is 2. So that's going to be square root of 3 over 2. So that's how we were able to build this table on the next page, is by finding the ratios from these two given triangles. Okay? So this is review. You guys should know these points. And we are going to make a new unit circle, paper plate unit circle, in class. So we will have a reminder of this as well when we do that. Okay. I'm actually going to stop here, and we'll deal with applications in the next lesson. All right. Thanks, guys.